Hi, everyone. I need a lot more energy in this room than what we've seen before. So I need everybody to take a deep breath and think about what it will take for us to go to the moon. And as someone who was a professor for 19 years, as someone who's an expert at crypto, I will tell you what will not take us to the moon. Copying ETH will not take us to the moon. Doing what we've been doing, except on somebody's laptop and calling it an L2, will not take us to the moon. ZK proofs, snarks, zero-knowledge proofs of different kinds, verifiable delay functions, verifiable random functions, accumulators, they will not take us to the moon. We need to think outside the box if we want to go somewhere. And doing more of the same stuff, doing more of the hexadecimal number sending, trying to educate your mom on how to set up her wallet and so forth, how to try to write smart contracts, they will not take us anywhere. I will tell you what I think is one of the interesting paths that can take smart contract programming to the masses. And that's what my talk is about today. It's about coin-operated agents. It's a provocative idea, it's an out-of-the-box idea, and it's something that we can do on Avalanche because Avalanche is a multi-chain system. We are not just a single chain. We have multiple different chains, each and every one of which can run a different virtual machine. And I will describe a virtual machine that we've been building that's at the intersection of AI and blockchains. And it's not some bullshitty thing about, oh, we're going to remember the provenance of stuff we fed into. You know, it's not about putting a little hash on a blockchain. Easy stuff. That's not what we do. I will tell you something provocative, something interesting, something that may or may not pan out, but I need you to at least think about it, and I think it's worth exploring for us to take programming to the next level. Just to illustrate my point, how many people here heard of AI? Hands up if you heard of AI. How many people here interacted with an AI agent? Almost everyone. How many people here know how to write Solidity? Much less. How many people here have deployed a Solidity contract? So what I want to tell you about is a scheme by which the first set of people can do all of the same things as the second set of people. Okay? So let me tell you how this works. So, ChatGPT is just the beginning. It's very exciting, very cool, and, but there's so much more we can do with what this is allowing us to do. So normally, how do you write a program? You go and learn Solidity. You then have some idea of what it is that you want to encode, right? You want to do something like you want to write a lending service. Now you need to write a crap ton of code about managing two pools, token A versus token B. Then you deposit collateral of token A so that you can borrow in token B, etc. To make it a little simpler, think about what you might have to do to write a smart contract about playing chess. You would have to encode all of the rules of chess from scratch into your code. You have to write all the rules about en passant, all about Zugzwang, everything, all of the niggly little details that make chess a little complicated, you have to encode in there. And then once you've written that code in Solidity, then you have to then deploy it. It has to get compiled. And you have to then check the ultimately deployed code to see if it is what you wanted to encode. And if there's any discrepancy between what you wanted to do versus what you ended up encoding, then there is the opportunity for a hack. And that kind of programming is not easy. You got to go get some auditor to go check what you did. They have to ensure that the code you wrote is good. It captures chess as you know it. But there's a much better way of interacting with blockchains. This layered approach of writing code, then translating it, then encoding it, then deploying it, that breeds errors. That gives rise to all kinds of problems because there's a discrepancy between what you have in your mind versus what you wrote in code versus what got compiled to bytecode versus what got executed at runtime. There have been many, many hacks because of that problem. As you know, the DAO hack, which I was involved in, the parity wallet hack, the Oracle mispricing attacks, unsafe math errors, these all happened because of these issues in the different layers of abstraction and because of the mismatch in different layers. Now, how can we eliminate the semantic gap? How can we get rid of the need for programming in the first place? I posit to you that if you could just interact with a blockchain the same way you interact with ChatGPT, life would be quite different. And that's exactly what we're building. So I'll skip this stuff. But what we're building is a new blockchain and a smart contract architecture that's based on natural language. So how does this work? On Avalanche, we are planning to deploy a separate chain which is programmed in multiple natural languages. When you want to, for example, create a chess game, you simply say, this transaction initiates a chess game where I play the white pieces. And the AI already knows the rules of chess. You don't need to encode anything because it already digested all of the information that's available on the internet and knows everything there is to know about chess rules. Suddenly, the task of programming is a lot easier because you don't have to start everything from scratch and encode everything from scratch. At the same time, there's no semantic gap. You're not specific. You don't have to learn Solidity. You simply say, this is a game of chess. Or if you want to create a lending service, you write in English, this transaction starts and creates a lending service that manages 2 pools. And you say it with those words. And you say it in ASCII text, the same way I just said it. You put a period at the end, and then you say, pool number 1 is convertible to pool number 2 under the following circumstances. There's an oracle, et cetera, et cetera. It's going to be a little bit of text, right? If you think about what Aave does or what Banky does, it's not that simple. And yet it's doable. And I suspect that all of you, every single one of you, without any additional instruction, know enough English or know enough of some language where you can specify what a lending service acts like. I bet most of you can't do this properly in Solidity. I bet most of you will end up having a reentrancy error if you try to do this in Solidity. I bet all of you will need to go through an audit if you had to do it in Solidity. But I bet almost all of us can do this in our own native language. And the nice thing, of course, is, if this ever works, what happened here? My device isn't working anymore. OK, next slide, please. Next slide, please. OK, thank you. So I want to talk to you about this coin-operated agent idea. Next slide. Guys, can we go to the next slide, please? Thank you. So it's a new kind of blockchain where there's a genesis block, and there are transactions. The transactions are in free-form text. They need not be in English. They can be in multiple languages. So I specify the lending service in English, but you can come in and interact with it in Arabic, or you can come in and interact with it in Tagalog, and you can even say things that normally would be very difficult to say. I hereby give you $5,000. This is easy. I can write a check, but I can do the following thing in this particular virtual machine. I can say, I give you $5,000 if and only if by June 15 you have raised the $5 million you need for the movie you want to make. And if you haven't raised the $5 million, then the money comes back to me. It's as if you took a check and you wrote something in the memo field that is as descriptive as you want it to be. And here is the kicker. Whatever you write in that field is executed by a trusted agent in the sky, by the AI, and you know that the AI is as trustworthy as an executor of an estate. It's as trustworthy as a lawyer with absolutely zero conflicts of interest. That's the vision. Next one, please. So the way this works is actually fairly straightforward. We plan to initiate a new chain, a new subnet on Avalanche, where each validator runs a standalone LLM. Thank you. Where each validator runs a standalone LLM. And there might be more than one LLM. You might decide, well, look, I like this LLM better. It speaks more languages. I like ChatGPT 4 better than ChatGPT 3.5. Or whatever LLM you like, you will have a choice of LLMs to pick from. Each validator keeps track of a mapping from addressees to token balances. That's all we need to keep track of. So you have 5 tokens, I have 15 tokens. I hereby give you some of them, etc. And as I give these tokens to you, there is no bytecode format. It's just free-form text. I really literally write I space hereby space give you da 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 da, and I simply specify what it is that I have in my mind in a natural language. And there's of course gas tokens that serve as the thing for this. And you know, as I mentioned, this transaction starts a chess game using standard chess rules, where Magnus plays the white pieces, the winner will take the pot of $1 million. I don't need to specify any of the additional details of a chess game. This transaction pays $5,000, etc. I talked about this. It's free-form English. There is no translation to any bytecode underneath. This is not an agent that sits on the front side. It's simply the opposite. It's exactly the opposite. It's an agent that sits in every validator, reads the blockchain, and then applies the intent of the person submitting the transaction. Now, there's a bunch of things that need to work, of course. One of the things that we need to do is we need to separate different styles of interaction, different prompts, so to speak. So your interaction with me should be separate from my interaction with you, and should be separate from the lending service that I built with him. So there's this concept of a sequence. It's kind of like a chat session. So this transaction creates a new sequence. This transaction builds on the previous sequence I had where I was donating some cash to a movie-making effort, for example. We need to, of course, have some congestion control mechanism. If you don't have this, if you have a gasless system, you have a DOS target, a denial of service target. So we need some kind of gas token. And that's actually fairly straightforward. We use AVAX for this. Fees are charged in full regardless of the outcome. This is not like an Ethereum-style thing where we charge you by the thing you do. We simply say, look, you want your transaction included? Well, you'll have to pay a flat fee. Not a flat, but you'll have to pay a fee. And whatever happens with your transaction, we will charge you the full fee. And this is a key insight, and I need you guys to all understand what we're trying to do and why it's different from other people that you might have heard doing the easy thing. At Ava Labs, with Avalanche, we never do the easy stuff. We're famous for bringing new science into crypto. And one of the things that we're doing here is the exact opposite of translating code into bytecode. We're not doing that. We are writing in English, and we're then executing things in the cloud, in the sky, on the blockchain by LLMs. No programmers. What does this mean? This is kind of crazy. You don't have to speak any kind or understand any kind of solidity, any kind of programming. You don't have to know what a for loop is. You don't have to know what a while loop is. You don't have to know what Boolean algebra is. You simply write things the way you've always been saying things to people that you know. So that means that everyone now is a programmer. If you speak a language, if you can hear me now and understand what I'm saying, then you're quite capable of programming this system. Now, yeah, that's kind of crazy. I don't know if it's good or bad. So I'll be fair and I'll talk about the downsides of this approach as well. There are quite a few. One of the things, of course, is who's good at this, right? You know, I would like to think I'm kind of okay at specifying things in English, but that's because I'm a programmer. So programmers are going to be good at this, I think. But I also think that a bunch of lawyers are going to be fantastic, because they're really good at using natural language to specify contracts, to specify what ought to happen, and making sure that the language is so bulletproof that an executor going through the same agreement will always come to the same conclusion. There are cool things you can do. Because there is this learned agent in the sky, you can appeal to its sense of common sense. You can say, look, you know, I'm not going to specify all the crazy conditions. Whenever there are 3 or more parties that are in disagreement, resolve it fairly. Now, I don't know what fair is, so I taught classes for 19 years, and students would come up to me and say, that's not fair. And I would say, look, you know, when you get older, you realize the word fair is completely undefined, right? I don't know what fair is. I couldn't tell you, like, there's a rule for fair. But I do have some gut feeling for what fair is. And I think the AI agents are getting to the point where they are realizing the similar concept of these abstract ideas. So they will be able to say, okay, well, look, if there are 3 people who are in disagreement in this particular configuration, this would be a fair outcome. And as I said, there is no need to specify minutiae. There is no need to go into every single detail the way you would have to with Solidity, because you can appeal to the common sense, to the learned knowledge of the LLM agent. There are some issues. You need determinism. So the current AI agents are not deterministic. They don't always yield to the same outcome. And so if you have a setup where, let's say, the lending service resolves in a different state on this validator versus that validator, we will have an issue. So one of the core ideas, or one of the technical challenges here, is making sure that the LLM that we use on the validators is deterministic, that all sources of non-determinism have been exterminated. This seems hard at first, but it's not actually that hopeless, because where there is non-determinism, we can appeal to a deterministic random number generator for the source of non-determinism and have the same outcome happen, even though there is some non-determinism underneath. There might be cases where it's actually difficult to understand what's going on when people interact with the same service in multiple languages. I've defined a lending service. He came in and interacted with it using Tagalog. What's the state of the lending service now? It might actually be difficult. So that's an issue, and that's something that we've encountered that could be a problem. Is this even a good idea? Right? Are there downsides with this? So I actually don't know. Okay? I wouldn't say that this is the next thing that's going to revolutionize everything. All I will say as a scientist is it's worth exploring, and this is exactly what we're doing. It could be the next thing that allows 1 billion people to use blockchains and without realizing that they're using a blockchain. At the same time, these agents are prone to hallucinations. They might suddenly say, you know, I take all the money and I use it to finance the next, I don't know, AI robot army. Could that happen? It's actually kind of possible. So there are some downsides with this approach. They could also say things like, I award all the money to that person. And why? Because, you know, they make up some hallucinated idea. And those would all be absolutely horrible outcomes. And that's one of the reasons why you don't see us turning this technology and throwing it over the fence and making it public yet. It's just not there. But in about a year or so, we expect this to be actually realizable and the hallucination problems controlled well enough that we could begin to do basic transactions with them. And then, of course, the final thing, how hard is it or how easy is it to use a natural language to define a contract? I'd like to think it's actually within the capabilities of most people, but it might not be. It might just be a specialized thing. Maybe we always need a lawyer to write out our contracts. I'm not sure about that. But it's something that's worth trying. It's much easier to try this approach than for us to try teaching Solidity to the masses. So that's why I think I'm really excited about this. Billions may be lost. I mean, I wrote here, billions will be lost. So people will end up writing something in English, the comma will be in the wrong spot, the AI will interpret it, you know, literally, and suddenly we go down a very, very dangerous and bad path. That can happen with this approach. And yet, I would posit to you, it's still far more promising than most of the other mumbo-jumbo that people are feeding you about what's going to allow these systems to scale. So I think that the LLM subnet is an experiment that we simply cannot afford not to perform. So that's why we're squarely in the middle of this. That's why we're really excited about it. And I will leave you with the simple message that Avalanche's multi-chain platform, the multi-chain architecture, allows us to experiment with groundbreaking ideas. And I hope you agree with me that this is at least, if not groundbreaking, it's at least worth exploring of an idea that can allow blockchains to be accessible to a much wider audience. Thank you so much.